Hello and welcome back to Prescriptive Analytics. In this lecture, we're going to discuss quantity discounts. And quantity discounts are modeled using binary variables and can cause a lot of issues. So this is particularly difficult. So I ask you to pay close attention to this problem, and I'll show you some tricks with binary variables that you can use. My name is Hari Rajagopalan, and I'll be walking you through this lecture. So we are going to look at two kinds of quantity discounts. The first one is absolute discount, and this is an example where if you buy 100 units, then you get a dollar discount for all 100 units. So for example, let's say each unit was $10. So normally you'd pay $1,000, but now for 100 units, you get a dollar discount for all 100 units. You only end up paying $900. And then there's incremental discount. And there you say, hey, if you buy up to 99 units, you have to pay $10. But the 100th unit, that extra unit, you'll get a dollar discount. So essentially, you'll end up paying, for 99 units, you'll end up paying $10, which is $990. And then the 100th unit, you'll get a dollar off. So you'll pay only $9 instead of $10. So you'll end up with $999. So two different kinds, each of it has to be modeled separately. So let's discuss both. So we're going back to the Blue Ridge hot tubs problem. Remember this problem where you had aquaspas and hydroluxes. This was the unit profit. Here were the resources, number of pumps, labor hours, tubing, and this is what was required. And I'm not going to get into this. Instead of X1 and X2, I'm using A and H. A is the number of aquaspas. H is the number of hydroluxes. And here's the model. And let's assume that if a Blue Ridge hot tubs produces more than 75 aquaspas, it obtains discounts that the profit is no longer $350, but it's $375. And if it produces more than 50 hydroluxes, profits increase to $325 rather than $300. Now we've got to remodel the problem. And how do you model it if it is only incremental discount? If you're looking at incremental discount, then if you produce more than 75, the profit will increase only if you have for the 76th, 77th, and 78th unit. For the first 75 units, it's still $350. And same thing for hydrolux when it's more than 50, or if it's an absolute discount. An absolute discount is that if you produce more than 75, then you automatically get the entire discount. So let's think about both these problems. The first one, let's look at the incremental discount problem. Okay, so let's talk about it. Before we model it, let's discuss it. And let me get my pen. And so incremental discount, we're saying you get $350, but if you produce more than 75, so 1 to 75 of aquaspas, you're getting it 375, and then 76 to how much ever, you get 375, right? So then we can call it A1 and A2. So the numbers produced from 0 to 75 will fall under A1, and A2 will be 76 and above, greater than 75, right? Similarly, you're going to have H1 and H2. This is going to be 300 and 325. This is going to be 0 to 50, and then 51 and above is that. So we're essentially breaking that variable into A1, decision variable A2, H1, H2. And let's think about this first. A1 can take any values from 0 to 75, right? If A1 is 75, only then A2 can have values, right? So first, A1 has to be filled first, and only then A2 can be filled. Now, if you look at this here, the computer is going to try and maximize it. So it will try to fill A2 automatically before it fills A1, because this is 375 and this is only 350. It's trying to put a bigger value. But you've got to put in a constraint which says A1 has to be 75. If A1 is 1 or 2, A2 will have to be 0. Okay? Similarly for H1 and H2. H2 can take values 0 to 50, and then once H2 is 50, then H1 can take values 1, 2, 3, 4. So long as it's below 50, H2 has to be 0. Right? And this is what you have to model here as you're thinking about this. This is essentially the model you got to think about. So let's look at the math model. We are defining A1, A2. These are your aqua spas before the discount. So here this will be 0 to 75. Cannot be a value more than 75. And then once, remember this is an incremental discount. And then once A1 is 75, A2 starts taking values 1, 2, 3. So if you have 80 units, A1 will be 75 and A2 will be 5. Similarly, this will be 0 to 50, and then this starts taking values, right? So you want two binary variables to handle this problem. If Y1 is 1, then A1 automatically becomes 75 and A2 starts having values. If Y1 is 0, A1 can be anywhere between 0 to 75, and A2 will have to be 0. Similarly for Y2. All right, so that's pretty much the definition. And so now we are looking at the objective function. Notice in the objective function that A2 values are always more than A1. Similarly, H2 is more than H1. So your computer is going to try to fill A2 faster. It wants to fill A2 than A1. It wants to fill H2 rather than H1 because it's a maximization problem. So when you look at the constraints, the first three constraints are pretty straightforward, right? You basically have pumps, labor, and tubing. Instead of A and H, now you have A1, A2, H1, H2. And I'm not going to go over this. All of you should be comfortable with this. But what I am going to go over are these three constraints for A1, A2, and H1, H2. So let's look at these constraints. The first constraint is that A1 is less than or equal to 75. Of course, you know that you cannot have A1 is up to 75, right? And now we are going to play with this Y1. So A1 is greater than or equal to 75 Y1. Because when Y1 is 1, you want A1 to be equal to 75, right? So if you take this, A1 will be equal to 75. And if Y1 is 1 multiplied by 1, which means A1 has to be greater than or equal to 75 and less than or equal to 75, which means the only value it can take is 75. So when Y1 is 1, A1 automatically becomes 75. But what happens if Y1 is 0? Then A1 will be greater than or equal to 75 multiplied by 0, which is 0. So A1 will be greater than 0, less than 75 will be 0 to 75. Correct? And let's look at the A2 value. A2 is less than some large value, big M, 999 Y1. So when Y1 is 1, A2 is going to be less than or equal to 999. It will never be 999 because these constraints will restrict it. So that's good. And if Y1 is 0, A2 is automatically less than or equal to 0. And we know that it's greater than or equal to 0, so A2 will become 0. So these three constraints, what it does is when Y1 is equal to 1, it allows A1 will be equal to 75, A2 will be greater than 0. If Y1 is equal to 0, A1 will be any value between 0 to 75. A2 will be equal to 0. The same thing goes for H1 and H2. The only thing you're going to use 50 there and Y2. All right. So let's stop here and look at how it's implemented in Excel. And once we do the incremental discount, I'll show you the absolute discount model. Okay, so we have the model here, and the setup is pretty much the same. The only thing I've done here is to create a boundary constraint where A1 is less than or equal to 75, H1 is less than or equal to 50, instead of making it a normal constraint. And also, if you see here, I've declared these as integers, these as binary right here. And because there is no y in the objective function, the coefficients are 0. If you don't have a variable, the coefficients automatically become 0. And you can see it's pretty much set up exactly the same way as the model. You guys should be comfortable with it by now. Okay, so and here are the linking constraints where you will be getting, you can look at the model and then fix them. It's pretty easy to set up and do. Okay, so take a look at this, and then we will move on to the absolute quantity discounts. Now that we have done the absolute quantity discount, let's take a look at, the incremental quantity discount. Let's take a close look at the absolute discount problem. Now, in the absolute discount problem, remember A1 and A2, A1 can take any value 0 to 75. The minute you are going to do 76, that value has to go directly here. A1 automatically becomes 0. So you can have A1, you can take values 1, 15, 70, 75. So long as it's here, A2 will be 0. But once A1, you need to produce more than 75, A1 automatically becomes 0, and A2 starts with 76, 77, and so on, right? That's what you've got to model here. So let's take a look at that model. So again, let's look at A1, A2, H1, and H2. Except remember now in this model, A1, if A2 has numbers 75 and above, A1 will be 0, right? So Y1 is 1. When Y1 is 1, you're going to produce, A2 will have numbers, A1 will be 0. When Y1 is 0, A2 will be 0, A1 will have numbers. So let's look at how we're going to do that. So maximization, this objective function is the same, but let's focus on these are the same, there's no change, but let's focus on these things. So let's start with Y1. When Y1 is equal to 1, the first one, A2, is greater than or equal to 75 multiplied by 1. So that's A2 is greater than 75. A1 will be less than or equal to 75, 1 minus 1, which is 0. So A1 will be less than 0, and A2 will be less than or equal to 999 multiplied by 1. So A2 will take values between 75 and 999, and A1 automatically is 0. When Y1 is equal to 0, A2 will be greater than or equal to 75 multiplied by 0, which is 0. A1 will be less than or equal to 75, 1 minus 0, so it will be less than or equal to 75. And A2 will be less than or equal to 999 multiplied by 0, which is 0. So A2 cannot take any value other than 0. A1 will be less than 75. So that's how this model works. So quantity discount model is important. Let's take a look at how it's implemented in Excel very quickly before we finish up with this video. So before we finish up, here is the implementation again. Again, really pretty straightforward. You will have to convert all of these into proper equations. So this will be A2 minus 75, Y1 greater than 0. So you'll have to expand it, make sure all the numbers are on the right-hand side, all the letters are on the left-hand side, and you'll have to implement it. So that's pretty much it. You will have to define Y1 and Y2 as binary variables, these as integers, and you'll notice that the solution here, unlike the incremental where you say 75 and 47, 50, and 28, here, once these are Y, automatically all the values jump to A2 and H2.